Okay, so now we're going to look at more in 2.3. And in 2.3, there's three different ways that we can find the equations. You can find an equation when you're given a point and a slope, which we'll look at first. You can find an equation when you're given 2 points, or you can find an equation from a point and another line equation. So the very first one we're going to look at is how to find a line when you're given a point and a slope. And the best way to do these is to use a flowchart. So we're going to find the line equation. Given a point and a slope. So this is our first one here. We're going to do these with a flowchart. So this is where we start at. And this is what we want to do. We want to find the equation of a line when you're given a point and a slope. And the first thing that we need to do is we need to use what's called the point-slope formula. So that's going to be our first step, is use point-slope formula. And that point-slope formula is y equals, right correctly here, y minus y1 equals m times x minus x1. Okay, so that is going to be your point-slope formula. And we're going to be using this a lot today. Now, once we've got our numbers plugged into our point-slope formula, then there are two ways of writing our answer. We can either write our answer in slope-intercept or standard form. So remember what slope-intercept form looks like. So slope-intercept form looks like y equals mx plus b, and standard form over here is ax plus by equals c. So these are our two ways that we can write our answer. So it'll specifically tell you to either write your answer in standard form or write your answer in slope-intercept form, one or the other. So this is our flow chart here that we're going to be using. Now, there are going to be three of these. There is one when you're given a point and a slope. That's this one. There's another one when you're given 2 points. And then there's a third one when you have an equation and a point. So let's make sure we get this one written down. And this one's going to be for finding the equation when you're given a point and a slope. And we're going to use what's called our point-slope formula first. And then the question will say either write it in slope-intercept form or in standard form. So I'll give you a few minutes here to write that down. Make sure you have it written down, very important. And then we'll look at some examples using the point-slope formula. this up a bit here. And you can just keep copying if you need to. We're going to apply our point slope formula. So we're going to find this equation. We're going to do two examples. One in standard, one in slope intercept form. So let's go ahead and find the line equation. In slope intercept form. And you're going to be given a point and a slope. And let's say you're given -3, 8, and a slope of -2/5. Just slowly move up so we can see if we got that first part down. So when we look at these, the first thing we need to identify is what we have. Now, what do we have? We are given a point and a slope. If you're given 2 points, you'll approach this differently. But in this case, we've got a point and we've got a slope. Now, how do we express our answer? Well, we need to express our answer in slope-intercept form, right? So we need to make sure when we work these out that we answer them in the correct way. So our answer is going to look eventually like this. Okay, y equals mx plus b. And there are different ways of working through these. You can plug the point in. I use point slope formula. I think it's the easiest way to do these. But there are other ways as well. You can also plug in your values and find your y-intercept. So let's begin. And the first thing we need to do, since we know that we have a point and a slope, and this is not a y-intercept. Right? If this would have been a 0, 8, we could have just jumped to our answer, but it's not. It's not a 0 here, it's a -3. So that means we have to use their point slope formula. And our point slope formula is y minus y1 equals m times x minus x1. We label our ordered pair just like it was going into our slope formula from 2, 2. So we label that as x1 and y1. And now we go ahead and plug in our values. And so we have y minus 8 equals -2/5, that's your slope, times x, and watch your double negatives here, minus a -3. So I'll give you a moment to see where I plug the values in. Because remember, this is y1 here, and this is x1 over here. Now we have to be very careful again with these. Just like when we worked out the ones that have the slope, when we used our slope formula. Double negatives, what happens with those? The double negatives now become positive, so watch out for that. And we're now left with y minus 8 equals, we're going to distribute that -2/5 through, because that's our slope here. And so that leaves you then with a -2/5 x. And double negative was positive. And +3, because that's 3 over 1, times a -2. Well, -2 times 3, that makes it a -6/5 there. Okay, so you just distribute it through. Remember, that 3 is like having a 3 over 1. So you just multiply the numerators together. Multiply the denominators, and that piece is positive. Now, we still need to go ahead and get this in slope-intercept form. So that means we need to solve it for y. And it's probably going to be easiest if we clear out our fractions. So I'm going to multiply everything by a 5 here to go ahead and remove those fractions. And so multiplying everything now by a 5, I get 5y minus 40 equals a minus 2x minus 6. We're going to add our 40 to each side. Okay, so we're just solving it for y. Why are we solving it for y? Because what do we want? We want it in slope-intercept form. And what does slope-intercept form look like? Just remember, this is slope-intercept form, so that's what it needs to look like. So we cleared out our fractions. We're moving that 40 over. So that gives you 5y now equals a minus 2x plus 34. We'll divide by our 5, and this is our answer now in slope-intercept form, which is minus 2/5 x plus 34/5. That is your answer now in slope-intercept form. And these do take a bit because it's all algebra. So we're not graphing these, we're just finding the equations. So we just have to use a lot of algebra. Okay, let's try another one. Let's find the equation of the line. I'll find the line equation. And in this case, we're going to find the line equation in standard form. So we're going to find our line equation now in standard form. And you're going to be given a point and a slope. So let's say for negative 5. And let's say we have a slope of minus 3. So we've got our point and a slope. So what are we going to use? We're going to use that flow chart. I'm just going to put it up here so we can quickly see it, and then we'll move back to the other one. This again is our flow chart. How do I know I use this flow chart? It says find the line equation when you're given a point and a slope. Do we have a point and a slope? Yep. So we know we use this one. What do? We use our point-slope formula. And in this case, we're going to want it to look like this in standard form. These are not difficult as long as you follow the directions. It's just a lot of algebra, and they take a little bit of time. So I always like to write up the formula. So we'll start by using our point-slope formula. And your point-slope formula is y minus y1 equals m times x minus your x1. And this is x1, and this is y1 here. Now that we've got our formula, we plug in our values. And so that's y, watch out for double negatives, minus 5 here equals minus 3 times x minus 4. Give you a moment to digest where I got all the points at, where I plugged them in. So I took my point and I labeled that x1 and y1. So I plugged in that with my slope of that negative 3. Now we can solve it, and what do we want it in? We want it in, very important here, standard form. Well, we know the double negatives at this 5 are going to make this then what? The double negatives here make this positive, and this negative 3 gets distributed through. And so we're left with y plus 5 equals now a minus 3x. And watch your double negatives. Negative and negative makes it a positive 12. Now, we're not going to solve it for y. We need to solve it to where it's in standard form, don't we? So right so far. How do we get this in standard form? Well, the x needs to be moved to the left, and the 5 goes to the right. So now we have our answer in standard form, which is 3x plus y equals 12 minus 5. That leaves you with a 7. And there is your answer in standard form. Give you a moment to kind of see what we did. So while you're writing it down, let's talk about what we did. Okay, you were given a point and you were given a slope. So we used that flow chart. We used in our point slope formula. We plugged our values in. We simplified it down. We cleared out our parentheses. We wanted it in standard form, so we moved that 3x over and that 5 over as well. Now we're going to look at another flow chart. And the next flow chart is when you have now 2 points. So you're not going to have a slope anymore. You're going to have to find that slope. So now we'll look at another flow chart here. And this one, we're going to be finding the equation of a line when you're given 2 points. Let me take a moment here to write this one up. So we're going to find the equation. When you're given 2 points. This is what we're going to look at here. We want to find the equation of a line when you're given 2 points. Now this one has an extra step from the last one. So in this case, we need to get a slope. So we're going to have to try and find our slope. And we do that by using our slope formula that we learned back in 2-2. So we want to find the slope. We use our formula, m equals y1 minus y2 over x1 minus x2. And that is your slope formula. Remember that formula? We used that back in the last section here. So once we have that, this out a bit, then we can proceed to use point slope. So we find our slope, and then we use the point slope formula. Which is y minus y1 equals m times x minus x1. And now we either use or write our answer, should say, in either slope-intercept or standard form. Remember, what do we know about slope-intercept? Well, slope-intercept is solve for y. And so that is y equals mx plus b. And standard form is ax plus by equals c. So we need it in either slope-intercept or we need it in standard form, one or the other. So this is the exact same thing that we did a moment ago, but what's the only difference? We have an extra step. And so that extra step is finding the slope to use in the point slope formula. As long as you follow these flow charts, these problems will make sense. If you don't use a flow chart, students get confused, but it's laid out in a very organized manner. You do this, this, and this. Okay, so let's go ahead and try one now. And we're going to find the equation. I should say line equation. In standard form. And you're going to be given 2 points now. So you're going to be given 5, negative 3, and 7, 4. So this one is very, very similar to the last two that we did. But before we jump in and use our our point slope formula, first thing we need to do is we need to come up with a slope to use in that formula. And we've got our 2 points. So we need to first label those 2 points. X1, Y1, X2, Y2. Is everyone with me so far? So we've got our 2 points laid out. We labeled them. Now, what does our formula say to do? Let's go back up and look if we need to. Our formula says we've got 2 points. So what do we do first? Find our slope. So let's do that. So we've got our points laid out and labeled. We're going to find the slope next. And that is m equals y1 minus y2 over x1 minus x2. So plug in your values and watch for double negatives. So let's see what we've got. We've got a minus 3, minus 4, right, there's your y's, over 5 minus 7. Minus 3 minus 4 makes it a minus 7. 5 minus 7 makes it a minus 2. Negative and negative, that makes it a positive. So my slope now is positive 7 over 2. Okay, so we've got that. So we've got our slope now. Okay. And now we do the exact same procedure that we did on the last two. So now we have our slope. We can now use the point that's provided, either one. It doesn't matter. Use one of the points provided. I just usually use the first one unless it has a fraction. So I usually would just use that first one. So now we're going to finish this out, and we're going to have to use point slope. And we're going to use that 0.5, negative 3. And that slope of 7 over 2. And point slope is y minus y1 equals m times x minus x1. And again, these problems take a little bit of time to go through. They're not really difficult, but it's very, very easy to lose track of where you're at or to make a sign error. So let's go ahead and fill in our pieces here. And this is your x1 again, y1. And don't forget, we want this in standard form. So make sure you remember, you want this one in standard form. So let's go ahead and plug our values in. And that makes it now y minus a minus 3 equals 7 halves times x minus 5. And what do we know? Well, first thing we're going to do is we'll get rid of the double negative. So that double negative is going to make it positive. And that leaves you then with y plus 3. And we're going to distribute that 7/2 through. And that 5 is a 5 over 1, and it is negative. So when we distribute that through, we now have 7/2 x. 7 times a negative 5, well, that makes it a minus 35 over 2. Is everyone okay with how I got rid of those fractions? Just make that negative 5 a 5 over, or negative 5 over 1, and then just multiply. 7 times that negative 5, that makes it that negative 35. 2 times that 1 down below makes it a 2 below. Now, we do want this in standard form, so can we have fractions in our standard form? Nope. So we need to clear out those fractions, and how do we do that? We need to multiply everything by a 2. So go ahead and do that, and now we're left with 2y plus 6 equals 7x minus 35. And we do want this in standard form. And so what does it mean when we want it in standard form? Well, if we want it in standard form, that means we need to get the x's and the y's together on the left. The x goes first, no fractions or decimals, and the x needs to be positive. So let's go ahead and move that 7x over. And while we're at it, we'll move the 6 over also. So now we have a minus 7x plus 2y equals a minus 41. Yep, we're not quite there yet. We can either divide by a negative 1 or just multiply it all by a negative. It's the same concept. I usually just multiply by a negative, but same thing as dividing. Distribute that negative through. And now we have it in standard form. And that is now 7x minus 2y equals 41. Let's try another one here. Now this one's going to have fractions in it. So the next one's going to be a little bit more difficult. And there is only one question like this in your homework, and that's 12. So this one's going to be like question 12 in your homework. So this one's going to be very similar to question 12 in homework 2-3. And let's say we have 3/2, comma, 1/2, and well, let's say 1/4, comma, minus 1/2. And I want you to find the equation in standard form. So this is what you're going to be given. And I want you to find the equation in standard form. This one's a little bit trickier because of the fractions, but we're going to work with the fractions. We'll clear them out where needed. And if you still struggle with question number 12, next week we can work it out as well. But I want you to try it in your homework, though. So this is going to be very, very similar to question 12. Okay, so let's see what we've got. We need to first find our slope. So we're given 2 points. So the first thing we need to do is find the slope. And that's m equals y1 minus y2 over x1 minus x2. Always label your ordered pairs x1, y1, x2, y2. And so what do we have on the top? And watch for double negatives. We have 1/2 minus a minus 1/2 for the y's. Down below we have 3/halves, my mistake there, minus 1/4. So I'm going to go ahead and make that a positive there. And we need to eventually clear out the fractions, but we can work with the numerator, the top half first, because it's going to be pretty simple. We have a half plus another half. We could clear out those fractions, but we've got a half and a half, so that makes that then a 1. So that's done there. Now, what about down below? Well, down below, what we need to do is we need to clear out our fractions or work with them. So we're going to try to work with them first, and then we'll use reciprocal and get our slope. So I want to take 3/2 minus 1/4. Well, we need to put them together, so I'm going to use a 2/2 here. You could clear out the fractions also by multiplying everything by a 4 at the very beginning, or you can work with them this way. I think it might be easier just to work with them this way. And 2 times 3, that's 6/4 minus 1/4. And that then makes it 6 minus 1 is 5/4. Okay, so is everyone okay with that so far? So we worked with our fractions. The numerator was easier. We just combined them together. And we got to this point. Now, how do we handle this? Well, this is a number divided by a fraction or another number. Either way, it's going to work the same. And how do we handle fractions when we have division? Well, we rewrite that as multiplication. Okay, so remember, when you divide, you can rewrite that as multiplication. So the numerator stays the same. So I can rewrite this as 1 times, flipping my denominator over, 4/5. And that gives you then, your slope is now 4/5. Remember how you work with a fraction over another fraction? You invert and multiply. So the top half stays the same. The denominator, what do? Flip it over and make it multiplication. You could have also just multiplied everything by 4. That would have been another option. There are many ways you could have worked this one out. I'm just showing you one way. But you could have just multiplied everything by 4 at the very beginning, worked with it that way, or you can invert and multiply here. Either way, we now have our slope. So now let's go ahead and move on. And now we're going to use our point slope formula. And that is y minus y1 equals m times x minus x1. And we've got our slope, which is 4/5. And we're going to use that first point, which is 3/2, comma 1/2 here. And this again is your x1 and your y1. Plug your values in, and you get y now minus 1/2 equals 4/5 times x minus 3/2. Distribute that 4/5 through, and then we'll clear our fractions. And there's only one of these in your homework, and you're not going to see this on an exam, but I did want to give you one of them in your homework like this, and that's question 12. There's only one of them. Now we're going to go ahead and distribute that 4/5 through. So that's y minus 1/2 equals now 4/5 x. Multiply across. So 4 times a negative 3. That's a minus 12. And 4 times 2. That makes it a 10. We want this in standard form. So we're going to multiply everything by a 10 to get rid of the fractions here. That'll clear out all of our fractions. So multiply it all by 10. And that gives you 10y. 10 divided by 2 is a 5, times a negative 1 makes it a minus 5 there. 10 divided by 5 is 2, times 4 makes it an 8x. 10 divided by 10, those go away, and that makes that a minus 12. Moving things around, we'll move that 5 over to join the 12, and we'll move that 8x over to join the 10y. We're almost finished. We've got another step or two left. And so now we have a minus 8x plus 10y equals a minus 17, isn't it?
Are we adding the 5?
Oh, wait, did I make a mistake? My mistake. Yep, I wrote it wrong. Sorry about that. Yep, that was my mistake. We should be adding that 5. Yep, got in a hurry here. Let me fix that so it comes out right. And now we've got minus 12 plus 5. That makes it that minus 7, doesn't it? Sorry about that. That was my mistake there. Okay, so we distributed through it. Yep, if I make a mistake, you should be sure and tell me. Sometimes I get kind of ahead of myself. But we cleared out our fractions. Now we move that 5 over with addition. Move the 8x over with subtraction. Is this in standard form yet? Nope. So we need to multiply it by a negative to clear out our negative in front. And now we have our answer in standard form, which is 8x minus 10y when we distribute through equals 7. And that's your final answer in standard form. Is everyone all right with that? And then I know that's a little bit trickier. The next ones that we're going to look at before we take a break are a lot easier. And we've kind of talked about this before. But let's remember slopes. And what is what? Now, we know that if the slope is positive or negative, that's a diagonal line. Okay, we covered that back in 2-2. What about vertical and horizontal? If I give you a horizontal line like this, so this one's horizontal. My slope is 0, and my equation is y equals 4, because it crosses the y-axis, and it's a horizontal line at 4. So, horizontal line has a slope of 0, and it is a y-line. Now, what about a vertical line? Well, vertical line is just going to be the opposite. So let's remember what a vertical line looks like. So here's going to be our vertical line here. And a vertical line, what do we know about our slope? Okay, it's vertical. My slope is undefined. And in this case, it's going to be x equals -2. Remember these back from the last section. Remember, horizontal lines have a slope of 0, and they are a y-line. Vertical lines have a slope that is undefined, and it's an x-line. The next ones that I'm going to give you are either going to have a 0 slope or an undefined slope, or they're going to be called a horizontal or a vertical line. And we need to find our equations here. So let's work with this one. So let's find the equation. And you're going to be given a point.
Wait, so on the vertical line it'd be x?
Yeah, remember, vertical lines are up and down and they cross the x-axis. So you look at the axis that it crosses. So horizontal lines, they cross the y-axis. And only the y-axis. Vertical lines, well, they cross the x-axis. So they're going to be an x-line. And it crosses that x-axis at -2. So let's go ahead and find this equation. And let's say you're given -4, 2. And you want it to be a vertical line. Now, we don't have to do any work with this. Okay, this one is one that we can just look at and tell what our answer would be. Well, what do we know? We know it's a vertical line, don't we? Okay, and if it's a vertical line, it has an undefined slope. And what kind of line is it? Is it an x line or a y line? It's a vertical line, right? So it's going to be an x line. And what's the x component of this ordered pair right here? Well, the x component of this ordered pair would be what? Would be -4. So that's our answer, -4, because it's a vertical line. Let's do a horizontal line. Again, we're just going to find the equation. And let's say you're given -3/8 and 1/4, and I want it to be a horizontal line. Okay. If you got this point, and I know it's a horizontal line, what does that mean? If it's a horizontal line, that's going across, isn't it? Okay. And what would that have for the answer? Is it an x line? Or is it a y line? Y line. And what's our y component? 1/4. So your answer for that one would simply be what? 1/4. Y equals 1/4 there. We want to do 2 more of these, and then we'll take a short break. We'll do one where it's 0 slope, and one where it's an undefined slope, just so we make sure we understand these. And again, we want to find the equation. And you're given a point, -8, 9, and my slope is 0. So if it's got a 0 slope, what does that mean? That means it's horizontal. Okay. And if it's horizontal, then what am I looking for? It's a y component, so my answer would then simply be y equals what? 9. That's it. These are simple, but students a lot of times try to make them more difficult than what they need to be. Now, you could use point slope with this one, and you'd work out with that 0 and make the other side go away. You get the same result. You still end up with y equals 9, but it's a lot more work. The next one, though, you can't, because undefined can't be used in our point slope formula. So let's do one with undefined, and then we'll take a short break. So let's find the equation again. And let's say you're given minus 5 minus 1 and an undefined slope. So if your slope is undefined, what does that mean? Well, that means it's a vertical line. And if it's a vertical line, that goes up and down. So that goes to your x component. And what's the x component of this ordered pair? Negative 5. So if your slope is undefined, it's an x line. And in this case, your x line would be x equals negative 5. Would it? So watch out for those. Anytime you have a 0 slope, or it says it's vertical or horizontal, or an undefined slope, it's either an x value or y value. That's it. So let's go ahead and take a short break again, and let's meet back at 10:35. So let's meet back here at 10:35.